I'm about to show you how to diagnose and fix the no display issue for the Bobcat controller base. For those of you who don't know me, I'm Nick. I started Nick's Electronics Repair about a decade ago, and since then have fixed over 27,000 devices. My first step for this repair is to open up the unit. I have 8 screws on the back. And now we should be able to just lift off the cover. Now we've exposed the circuit board inside of the controller base. Now more specifically, we're going to want to pay attention to this chip right here. This is the IC that controls the display. It is rare for the IC itself to fail, however the components to the right of it typically do. Now starting from the top, we have R24, R25, and R26. All 3 of those are resistors that are labeled 1002, which means they are 10,000 ohm resistors, or 10K. I'm going to start by taking a measurement, and the first one is reading 9.97, so that's within spec. Let's take a look at the second one, 9.96, also within spec, and the third one, I cannot get a reading. Let me try again. So the third one is reading open. That means it has failed and needs to be replaced. So that could be why the display is not working. However, let's go ahead and check out the other components. Next, we have R27, which is a 68 ohm resistor, and that one is reading 7.9 kilo ohms, which is much too high. That's 7,000 ohms. Next we have R32 over here. That one reads 821, which means it's an 820 ohm resistor. Let's take a measurement. Also reading 7.39 kilo ohms. So that's much too high again. It means that resistor has failed and also needs to be replaced. So now we found 3 defective resistors so far. Next we have R33, which again is labeled 1002, so a 10 kilo ohm resistor, and it seems that one is reading completely open as well. So that one is also defective, needs to be replaced. And lastly, we have R34, which is labeled 5112, which is a 51 kilo ohm resistor. Let's take a measurement and see what we get. And that one is reading mega ohms, so 33 mega ohms. That's 33 million ohms. Again, that means it has failed and also needs to be replaced. Now, even though some of the resistors had proper reading, we are going to want to replace every single one of them, as the ones that have not yet failed may be near their end of life. So let's start by replacing the 10 kilo ohm resistors first. For the removal process, we're going to start by adding solder to both sides of the resistors, going back and forth until we free it up. And these resistors were actually coated with some silicone, which I did remove off screen, but there is still a little bit of that coating left on the resistors, which is making it slightly harder for the heat transfer between the iron and the joint. And then we have our last resistor down here. Now we'll remove some of that excess solder with our desolder braid. Then we'll give that just a quick cleanup with some isopropyl alcohol. Next, I'm just going to prep the pads by adding a little bit of solder only to one side. And those are actually very large blobs, probably more than I need. And now I'm going to melt the solder and slide in the replacement resistor. And we'll repeat that process 3 more times. Now I'm getting some small solder horns, not perfect, but we'll touch that up in a moment. To make it easier for myself, I just rotated the board 180 since I'm left-handed. And now we'll add solder to the other side. And finally, to make everything pretty, we're going to add a little bit of flux. Get some extra flux on the syringe tip. And now we'll touch it up. Another 180-degree turn. And we'll touch up the other side now. Let's replace the 68 ohm resistor next, R27. Same process, adding solder to both sides, knock it off, remove that excess solder we just added. So at this point there is a lot of flux in the area from replacing the 10 kilo ohm resistors. So let's just do a quick little cleanup of the vicinity. And that's not perfect, but that's good enough for now, at least to install the couple remaining replacements. The resistor is upside down, but that's okay. And resistors also don't have polarity, just in case you're wondering. So it doesn't technically matter what orientation I install it at. Same thing, we'll add just a little bit of flux, touch up our joints. All right, let's move on to the next one. 821, which is R32. So instead of 821, this one is 8200, which is the equivalent of 821. So let's touch up R27 real quick. There we go. And there goes R32. Same thing, quick little touch up with our flux. And finally R34, which is the 51K. Okay, so that does look to be all of the resistors. Let's do a final cleanup, and then we'll do a final check with the multimeter to make sure all of our resistors are reading proper readings. Now, quick heads up, something we might find out is that some of these might actually read a lower resistance than their marked resistance. And that's going to be because they are in circuit. If you recall, the first three resistors were 10 kilo ohm resistors. We are getting 10.01. So exactly 10 kilo ohms, more or less. 9.98, 9.98. Now R27 was our 68 ohm resistor, and I think that one had failed open. And we're reading about 64.7 ohms, so it's slightly lower. Again, that's because it is in circuit, so that's actually normal. Next we have R32, which was the 820 ohm resistor, and that one's also going to be much lower than anticipated because it is in circuit. So this one's reading 335, and that is exactly what we're expecting because of the fact that it is in circuit. Next we have R33, which was another 10 kilo ohm resistor. We are now getting 10.02. And then lastly, we have our 51 kilo ohm resistor, which I believe had failed open or was 33 mega ohms originally. Let's see what we get now. And we are getting 50.5, which is also what we're expecting when it's in circuit. So it does look like we may have resolved the issue. Let's go ahead and plug it back in, turn it on, and see what we get. And sure enough, we have our screen again. Now there are some other issues. It does look like our gauges are not moving at all. So let's tackle that next. Now for the repair of the gauges, we are going to go through a very similar process that we just did for the display repair. The only difference is instead of this IC, we're going to be focusing on this one over here. So just above it, we have IC labeled U4, and that one controls the gauges. Same process, we're going to check all of the resistors on the perimeter of the IC chip. Now to the left, we have 4 of them, all of which are 10 kilo ohm resistors. 1002. So again, this one is showing 2.0 mega ohms, so that's 2 million ohms, much more than the 10 kilo ohms we're supposed to see. So that one will need to be replaced. This one's reading 10.01, so that one's good. Next one is reading 14 mega ohms, so again, has failed and needs to be replaced. And the top one does seem to be correct, 9.95 kilo ohms, that's within spec, technically does not need to be replaced. Now we also have one more 10 kilo ohm, which is the second from the top over on the right side. And that one is 9.98 kilo ohms, so also good and also technically does not need to be replaced. Now the remainder of the resistors around the ICU4 are going to be 470 ohm resistors. So let's take measurements, and it seems like the top one here, I cannot get a measurement at all. Oh, we got 20 mega ohms for a split second, but it's open. So that one definitely needs to be replaced. Top right, same thing, can't get a measurement, can't get a reading, can't get a reading, and can't get a reading. So it does look like all of my 470 ohm resistors are failed completely open. So we'll definitely need to replace those. Now again, same as the other set of resistors, we are going to want to replace every single one of them, even the working ones, because they may be near their end of life. When I turn the unit on, we can see that the gauges are moving, but they're moving very, very slowly. Also, once they reach the end of where they're supposed to go, they're also still going and struggling. And you can hear that. When I turn the unit off, the gauges are also very, very slow to move back to their reset positions. I'll do it one more time with the microphone right next to the gauges so you can hear that clicking sound I'm referring to. And it keeps going. So for these, I didn't actually remove the silicone yet, so we'll go ahead and do that right now. And essentially, I'm using a metal brush just to scrub the resistors. All right, and we will repeat the same process as before. Add solder to both sides of the resistor, go back and forth, and remove it. Oh, and it looks like I did make a mistake. R18 is a 10 kilo ohm resistor, but it did read open in circuit when we were doing our checks. I mistakenly called it a 470 ohm resistor earlier. Same as before, quick 180 flip. All right, and then we'll touch up with extra flux all of the resistors once we've replaced the 471s, which are the 470 ohm resistors. We'll just do all that in one go. And finally, we'll add our flux. Final cleanup with isopropyl alcohol again. Okay, and this is our final product. Looks pretty good. Final multimeter test, 9.98 kilo ohms. That's good. 10 kilo ohms, that's good. 9.98 and 10 kilo ohms. So if you recall, I think 2 of these 4 were defective and open. Second from the top was another 10 kilo ohm resistor. Now we're getting 9.99. And then second from the bottom also was open. I had called it a 470, but it was a 10 kilo ohm, and we're getting 9.96. All right, everything else is a 470 ohm. And those were all open, 0.470 kilo ohms, so that's 470 ohms. 0.47, all good. 0.471, also within spec, and 0.470. So that does confirm it. We have successfully replaced all of the resistors. Let's do a live test and see what we get. All right, let's turn it on. Okay, it does look like they're moving faster, but they are still struggling a little bit. So I'm thinking our next step is to actually replace the stepper motors themselves. So the resistor repair here did get us halfway there, but in order to get a full complete fix, we're gonna have to replace these 2 stepper motors next. In order to do that, we will have to disassemble this unit further. We're gonna disconnect the buttons over here on the right and lift the circuit board out. And we have 4 more screws we need to get to. Now the last part holding this piece in are actually the needles here. So we'll need to remove them in order to be able to lift this off. We'll need to flip it over, and I'm actually gonna pull the circuit board away from the gauges and needles. Okay. And that's our first one. And that's our second one. Okay, we've now exposed the solder joints for the stepper motor. So there are 4 solder joints here that we'll need to desolder in order to remove the original stepper motor. For these, I'm gonna start by adding some new solder, and that's so that I can make sure to have really good flow on my joints. And next, I'm gonna use my desolder wick to wick away that extra solder we just added, and of course, the original solder as well. We'll repeat the process 3 more times. Taking a closer look, it looks like this one is free and this one is free, but these 2 over here and over here are not. So we'll give it another desolder round. Okay, let's see, is this one free? It is, and this one, not quite. We're almost there. Okay, I think I got it, and we're able to push it through. There we go. We're gonna repeat the same process on the one to the right. Oh, and I think we just got it loosened up. Yep, there we go. We're gonna feed our replacement stepper motor in, and let's add our solder. And our stepper motor is locked in. One more time. Now let's assemble it and give it a test. And let's see what we get. Okay, so it does look like the stepper motors are still having that same issue where they're still struggling afterwards. Let's turn it off. They are definitely moving faster than before, but I think that was more from the resistor replacement than it is the actual stepper motor replacements. So I'm thinking these didn't necessarily need to be replaced, but they do fail, so it's a good thing we replaced them anyways. So at this point, because we found so many defective resistors both around the display IC and the stepper motor IC, I'm assuming there's a few other resistors somewhere else on the circuit board that are defective and are the reason why we're getting a little bit slower needle movement than what I'm expecting to see, as well as them trying to go past their maximum and again, back below the 0 so much. So I'm gonna do a little bit more diagnosing and poking around and we'll see what we find. So after further checks, I found 14 more resistors that are out of spec, some of them being over here, a good chunk of them right in this area, a couple over here, over here, over here, and over here. I'm gonna go ahead and do all of those replacements off screen because at this point this video is getting pretty long, and we'll reconvene once I've completed those replacements. Let's take a look. Look at that. So actually there's 3 things that are different from the last set of resistors I replaced. Okay, so as I turn on the unit, the gauges of course are moving quickly as they should, but something else is earlier when I was turning it on, it took a full 4, maybe 5 seconds even between the time I flipped the switch to the time the unit actually turned on. So there was a little bit of a delay. That's no longer the case. The gauges are moving quickly now. And then the last thing is we had a little bit of a flicker from some of the lights. That is no longer happening. So we have resolved all 3 of those issues. So I'm just gonna point it out. We had 2 resistors over here that were replaced. Pretty much every resistor in this vicinity. We also replaced all of these guys over here, this 100 ohm resistor, and then we had 2 more 10K ohm resistors here. Now there actually is just a few more resistors that are defective and causing different issues with this unit, but that's something we're gonna do in a different video because we have successfully repaired the display issue as well as the gauge issue. So if you have a Bobcat controller base that you'd like to send in for us to fix, we do offer the flat rate services which come with a 1-year warranty. Those are available on our website. I'll link that in the description below. If you found the video helpful or useful, leave us a like, subscribe for more content, and thank you for watching.